Dear friends, welcome to a personalized episode of Enlighten Me. Today we will explore the impact of AI on Wikipedia, how startups balance user feedback with product vision, and the challenges of achieving certainty in coding. Stay tuned for insights and discussions. What impact is the rise of artificial intelligence having on Wikipedia, and what does it mean for the future of the free encyclopedia? In our rapidly evolving digital landscape, artificial intelligence has made significant strides, particularly with the development of large language models like ChatGPT and Google Artificial Intelligence Overview. These models rely heavily on vast amounts of data to learn and generate text, and one of their primary sources of information is Wikipedia. However, this symbiotic relationship between artificial intelligence and Wikipedia is not without its challenges and implications. Wikipedia, the world's largest repository of human knowledge, is a free-to-use platform created and maintained by volunteers. The rise of artificial intelligence tools trained on Wikipedia data has introduced a peculiar disconnect. While artificial intelligence tools disseminate information originally sourced from Wikipedia, they do not necessarily direct users back to the site. This trend could potentially undermine the engagement of Wikipedia's volunteer editors, a concern voiced by Lane Becker and Chris Albon from the Wikimedia Foundation. Lane Becker explains that despite claims of declining traffic from sources like SimilarWeb, internal analytics indicate that Wikipedia's page views have remained stable, oscillating between 15 billion to 18 billion views per month since October 2020. Chris Albon adds that metrics such as unique devices and Google search clicks have also remained consistent, suggesting that Wikipedia's readership has not drastically diminished. But why does this matter? Wikipedia's traffic is not directly tied to revenue since it operates without ads. However, the platform's visibility is crucial for attracting and retaining volunteer editors and securing donations. If fewer people visit Wikipedia, fewer might be inclined to contribute, either by editing articles or financially supporting the platform. One significant concern is how artificial intelligence might affect human motivation to contribute to Wikipedia. When users access information directly from artificial intelligence tools like ChatGPT or Google Artificial Intelligence Overview, they miss the opportunity to engage with Wikipedia's community and potentially become contributors themselves. This separation could lead to a decline in the number of volunteer editors, jeopardizing the quality and upkeep of the site. Moreover, the issue of attribution is critical. Artificial intelligence tools often fail to credit Wikipedia as the source of their information, which not only diminishes recognition for the volunteers, but also risks spreading misinformation. Without clear attribution, users might find it challenging to verify the accuracy of the information they consume, leading to a potential increase in falsehoods and hallucinations generated by artificial intelligence. Despite these challenges, there are opportunities. Lane Becker suggests that artificial intelligence could help scale the efforts of Wikipedia's volunteer community, making knowledge more accessible in various languages faster than humans alone could manage. However, this requires responsible use of Wikimedia's APIs and clear recognition of the human contributions behind the data. One solution to address the financial sustainability of Wikipedia amidst these changes is the introduction of Wikimedia Enterprise. This paid product allows commercial enterprises to reuse Wikipedia content at high volumes in a way that aligns with their business models while contributing to Wikipedia's financial health. Google was the first for-profit customer, followed by other entities like Yep.com. In conclusion, the relationship between artificial intelligence and Wikipedia presents both challenges and opportunities. While artificial intelligence tools enhance the accessibility of knowledge, they must responsibly credit the human efforts behind it. Ensuring this balance is crucial for the continued growth and maintenance of Wikipedia's vast repository of human knowledge. Now let's move on to how startups and enterprises balance user feedback with product vision to avoid creating unfocused products. When should you listen to your users and when should you follow your product vision? This question is critical for any startup or enterprise aiming to build products that not only meet user needs, but also set the stage for future innovations. Let's begin by acknowledging that listening to users is essential for avoiding the pitfall of building products nobody wants. Paul Graham in How to Start a Startup famously advised, "The only way to make something customers want is to get a prototype in front of them and refine it based on their reactions." This advice is sound, but comes with a caveat. You must know which users to listen to and how their feedback fits into your broader product vision. If you prioritize user feedback over your vision, you risk becoming a feature factory that serves immediate, surface-level needs but neglects long-term strategic goals. Consider a hypothetical scenario where you're developing an AI-powered CRM system. Your vision includes ambitious features like predictive analytics and advanced automation. However, users repeatedly request superficial features like dark mode, custom fonts, and zodiac sign profiles. If you constantly cater to these requests, your product could become cluttered and unfocused, ultimately failing to achieve its full potential. This conundrum isn't just hypothetical. Take Slack, for example. April Underwood, Slack's former chief product officer, emphasized their commitment to a clean, intuitive interface focused on communication. Slack resisted the temptation to expand into adjacent work streams, thereby maintaining a focused, effective product. The key is to be directionally correct and opinionated in execution. Users know their pain points, but it's up to you to solve these problems in a way that aligns with your vision. Listen to the why behind user requests, but be deliberate about the what you build. For instance, if users ask for an export to PDF feature, the underlying issue might be data portability. Instead of a simple export function, you could develop APIs or native integrations with data providers, enhancing your product's interoperability and long-term viability. Now let's look at real-world examples of companies that successfully balanced user feedback with their product vision. Basecamp is a prime example. In 2014, the company, then known as 37 Signals, decided to discontinue successful products like Highrise and Campfire to focus solely on Basecamp. Despite customer backlash, this decision allowed them to concentrate on delivering the best possible project management tool. This focus has paid off, as Basecamp now serves over 75,000 organizations globally, with more than 3.5 million registered accounts by 2021. Brex, a fintech company, also made a controversial but visionary decision. Initially serving a broad range of clients, Brex chose to offboard its SMB customers to focus on enterprises and VC-funded startups. While this move upset many paying customers, it aligned with Brex's vision of helping tech startups succeed. Apple's decision to remove the headphone jack from the iPhone 7 in 2016 is another pertinent example. Despite initial outrage from customers, Apple stuck to its vision, leading to the overwhelming success of AirPods and setting an industry trend that other manufacturers followed. In summary, balancing your product vision with customer feedback is an art that significantly influences the success of your startup. Companies like Basecamp, Brex, and Apple have demonstrated that you can build products that are both visionary and user-centric by combining user insights with a strong, clear vision. Now, let's move on to the challenges of achieving certainty in coding and the importance of maintaining a skeptical mindset in programming. Can programmers ever be absolutely certain their code is correct? It's a question that has puzzled developers and software engineers since the dawn of computing. Today, we will explore why the quest for certainty in coding is elusive and what you can do to mitigate the risks of bugs and errors. Let's start with the notion of certainty. Imagine you've just written a piece of code and it passed all the tests. Your peer reviews it and gives the thumbs up. So, is your code foolproof? Unfortunately, the answer is no. Why? Because verifying the correctness of all possible scenarios, machines, and times your code might run is an impossible task. Let's break this down. When we say that code passes tests, we mean it has succeeded in specific, predefined scenarios. However, the absence of failing tests doesn't guarantee the absence of bugs. This is a concept known as a false pass. Just because something works in one context doesn't mean it works universally. Moreover, even if you could write a formal proof for your code's correctness, you'd then need to prove the proof itself is correct. This would lead to an infinite loop of verification. So, while absolute certainty in coding is unattainable, despair is not the answer. Instead, we can aim for a greater understanding and due diligence, especially through the lens of abstractions. Abstractions are mental models that simplify complex systems. In programming, they help us manage the intricacies of hardware and software without delving into their minutiae. For instance, the basic elements of programming languages, loops, conditionals, functions, are abstractions that hide the underlying hardware-level details like CPU instructions and memory management. Consider driving a car. Most drivers understand the car as an ignition, accelerator, brake, and steering wheel. They don't need to know how the engine works to get from point A to point B. However, this abstraction can fail when it comes to maintenance. If a driver ignores oil changes, the engine could break down, despite the car being perfectly drivable in the short term. Similarly, in programming, while abstractions allow us to write and run code efficiently, they can also leak. Joel Spolsky coined the term leaky abstractions, which suggests that all non-trivial abstractions will fail to some degree. For example, garbage collection in languages like Java removes the burden of manual memory management, but it can also introduce latency jitters. C++ smart pointers make memory safer, but they can still cause issues if raw pointers are mishandled. So, should we discard abstractions altogether? No. Beneath every abstraction lies another abstraction, much like peeling the layers of an onion. For instance, understanding a car involves chemistry, which involves physics, which involves mathematics, and so forth. As programmers, we should view our knowledge as a house of cards built on leaky abstractions and assumptions. This requires a healthy dose of skepticism. Trust, but verify. To mitigate risks, always verify the information you receive. Test your beliefs by trying to disprove them. If your code change passes tests, run the tests without the changes to ensure they don't have bugs that make them always pass. If you refactored the code, ensure there are tests that actually run the refactored code. Always measure the impact of your code optimizations to ensure they deliver the expected improvements. The most daunting challenge is dealing with unknown unknowns, things you don't even know you're unaware of. These can include issues like SQL injections from unsanitized user inputs, character encoding mishaps, or Java heap size limitations. The best way to manage these is to dig deeper than necessary when learning something new. Read extensive documentation, watch conference presentations, read blog posts, and even skim through man pages of CLI tools. In conclusion, while you can't achieve absolute certainty in coding, you can significantly reduce risks by continually educating yourself, questioning assumptions, and verifying your work. This balanced approach between ideals and real-world constraints will help you become a more capable and principled engineer. Today we explored the impact of AI on Wikipedia, the balance between user feedback and product vision, and the challenges of achieving certainty in coding. Stay tuned for more updates. Dear friends,